Hello class, so we're starting up again, 7.2, running through some more identities. So last time we only talked really about the identities that we had talked about in chapter 6, which were the Pythagorean identities and the even and odd and stuff like that. But we're going to learn some brand new ones today, and in this video, and the first one is called the sum identities, and the second one's called the difference identities. And so they're kind of peas in a pod. The way it works is that anytime you have two parts inside of your cosine or your sine, so these two are angles, these alphas and these betas, these are angles, and so you're adding an angle or you're subtracting an angle in either the sine or the cosine, you get these different identities. And so the first one says that if you have cosine of alpha plus beta, the way it works is that it actually ends up being cosine alpha times cosine beta minus sine alpha times sine beta. And so that means that we no longer have to add the angles inside the cosine. We can just split it up and multiply like that. And there's identities for all four. If you have a sum or addition or difference or subtraction, you just have these four right here. Now, I don't require my students and y'all to have these memorized. They don't come up as often, and they're not as important to have in your memory banks. We can use them we'll have a table of identities for you. So you don't have to memorize these per se, just know how to use them and when to use them. And there's also one for tangent, and it's right here. And we're just going to run through on these examples how to do some of these, just do them properly. So the first one says let's use the difference formula to find this exact value, cosine of that guy. So first things first is that my alpha is going to be 5 pi over 4, and my beta is going to be pi over 6. So pi over 6, alpha is 5 pi over 4. Okay, and this is, since they're getting subtracted, this is going to be the cosine, the difference of cosines. So I'm going to go ahead and just apply that formula and see where it takes me. And of course we're going to use the unit circle when we have to eventually. So the formula is that cosine of alpha minus beta, it's right here, is equal to cosine alpha times cosine beta. So it's going to equal cosine of alpha, which was 5 pi over 4, times cosine of beta, which is pi over 6. Okay, and then where the cosine works is a plus sine alpha sine 5 pi over 4 times sine beta, which is pi over 6. Okay, and from there, now we don't want to leave it there if these are standard angles. So these angles are all in the unit circle, they're in standard angles, so it's not like pi over 12 or something like that, or 7 pi over 9 or something like that. So we can go ahead and then just actually evaluate to see what those equal. Just making sure my mic works. Okay, and we'll use the unit circle. So this is 5 pi over 4. So 5 pi over 4 is, so this is 1 pi over 4, 2 pi, 3 pi, 4 pi, 5 pi over 4 is over here. Cosine is negative in this quadrant, so it's negative root 2 over 2. Cosine of pi over 6, so that's the smaller angle. That means the cosine is bigger, so it's root 3 over 2. And then it's plus sine of 5 pi over 4, which is down in this quadrant again. That's pi over 4, and so that's negative root 2 over 2 as well. So negative root 2 over 2. And sine of pi over 6, well, that's when the angle's small, the y value is small, so it's 1/2. And we go ahead and just multiply, and we get negative root 6 over 4 minus root 2 over 4. There you go. So that's the answer. So again, that just took knowledge of knowing our unit circle, but also first applying the formula. And oops, it's wrong. Root 3 over 2, comma 1/2. So now that was kind of cooked up for us because the angles were written. But what about the real use of this is that when we don't have these angles separated. So this is 75. So the problem wants me to do 75. Now I need to write this as a sum of, or a difference of two standard angles. And I really only have, the standard angles are really only 30, 45, and 60, and some multiples of those, right? So how can I get 75 out of that? Either by adding or subtracting. So I think if I add 30 and 45, that equals 75. So this is cosine of 30 degrees plus 45 degrees. Aha. So this now is in terms of standard angles. So my alpha is 30 and my beta is 45 degrees, excuse me. And so we have 30 plus 45, and so that means I'm going to use the formula for cosine that's adding. And so it's right here. So I'm going to use that formula. Cosine, cosine minus sine, sine. So it's going to equal cosine 30 cosine 45 minus sine 30 sine 45. Okay, and cosine of 30, then okay, then again we'll just use our unit circle knowledge. Here's 30 degrees, and that point is root 3 over 2 comma half, and the 45 is the root 2 over 2 comma root 2 over 2. And so cosine of 30, that's going to be the x value right here, so root 3 over 2 right there. Cosine of 45 is root 2 over 2. Sine of 30 is, when this angle is small, the sine is small, so it's 1/2. And sine of 45 is root 2 over 2. And then we just go from there. So it's going to be root 6 over 4 minus root 2 over 4. Okay, so that's it. So again, just using the formula, in this case we did the sum of cosines, which is right here. It becomes cosine, cosine minus sine, sine. And we just had to use our unit circle knowledge to go from there. Now, algebraically this could be combined, but I don't really care. If you left it like that, that's fine. And that's also the answer. Same thing with up here. This is the same thing as negative root 6 minus root 2 over 4. Either way is fine. Okay, so let's do a couple more. So, the difference formula to find the sine of 105. Again, I only really have 30, 45, and 60. So I want to use the difference formula here. We could use the sum formula, but I just want to get a little more practice. So the next one would be 90, and then 120, 135, and 150, and then 180. So how can I make 105 out of that? Well, I think if I do 135 take away 30, I think that equals 105. Okay, good. Check mark. So that's what I'm gonna use. So I'm gonna call sine 105 is equal to sine 135 minus 30. I put degree symbols on there. Okay, so that's my alpha and that's my beta. And so I need the difference of sine formula, and that's up here. Difference of sine is sine alpha cosine beta. Okay, I'm gonna write that down. Sine alpha cosine beta. So I'm looking right here. Minus cosine alpha sine beta. So minus cosine alpha sine beta. And so that means that we get, okay, so that means it's going to work out this way. Sine alpha, so sine of 135. Cosine. Now beta is 30 degrees, it's not negative 30 degrees, so beta is just the angle, 30 degrees. So it's going to be cosine of 30 degrees minus cosine of alpha. Alpha was 135 degrees, and sine of beta. Beta was 30, so sine of 30. So again, I'm visual, so I always go back to my unit circle. I draw my unit circle. I plot 135, so this is 45, this is 90, this is 135 over here in this quadrant, and so that is negative root 2 over 2, comma, root 2 over 2. And then I also need 30 degrees, which is right here, and that's going to be root 3 over 2, comma, 1/2. Okay. And so then we just start plugging and chugging. So sine 135 was the positive root 2 over 2. Sine is positive in this quadrant, in quadrant 2. Cosine of 30 is root 3 over 2. Okay, oops. Minus cosine 135 was the negative root 2 over 2. That has a negative sign right there. And sine of 30 was 1/2. Okay, and so this equals root 6 over 4 minus, so it's going to be a minus, so see, this is a minus and this is a minus, so it actually becomes plus, and it becomes plus root 2 over 4. And so we can combine those, root 6 plus root 2 over 4. I don't really care either way. If you left it this way, that's fine, but that's fine. Okay, again, just using the identity and making sure we know a unit circle. And the last one we're going to do before we verify an identity is we want to find the exact value of tangent of 5 pi over 12. So we've been doing the last couple in degrees. Why don't we try to do it in radians? So again, for radian measure, 5 pi over 12, the only ones that we have are, pi over 6, pi over 3, pi over 4, pi over 2. I should flip-flop these, I guess, but I'm trying to go in ascending order. It's hard to tell with the 5 pi over 12, but I think if I split it up like this, if I have 3 pi over 12 plus 2 pi over 12, so that does equal 5 pi over 12. And check it out. This simplifies as pi over 4, and this simplifies as pi over 6. So it took a little knowledge of these fractions, but I was able to figure out that 5 splits up as 3 plus 2, and those are nice. Those are standard angle. That's standard angle. That's standard angle. So that's how this one flips up. So it's going to be tangent of 5 pi over 12 is going to split up as pi over 4, which is right here, plus pi over 6. So that tells me that this is alpha equals pi over 4, and this is beta. Beta equals pi over 6. So I just need to know the identity. This is the addition inside of a tangent rule. So it's right here. So it's tangent alpha plus tangent beta. So tangent alpha plus tangent beta all over 1 minus tangent alpha tangent beta. 1 minus tangent alpha tangent beta. So 1 minus tangent alpha tangent beta. Okay, so for this one, that's going to become tangent of pi over 4 times tangent of pi over 6. Oh, sorry, plus right here, over 1 minus tangent, this is where the multiply happens, tangent of pi over 4 times tangent of pi over 6. Okay? And tangent of pi over 4 is 1. Whoa. And plus, okay, so tangent, is derived from the unit circle. So pi over 6 is right here. So again, we draw our things here, root 3 over 2, comma 1/2. And so tangent is y over x, so yx. So it's going to be 1/2 over root 3 over 2, so tangent. And that's going to be flip up 2 over root 3, which is 1 over root 3, which we can rationalize, and so it's going to equal root 3 over 3. So tangent right here at pi over 6 is root 3 over 3. So this is root 3 over 3. All right, and then this is going to become 1 minus, again, tangent of pi over 4 is 1. The reason tangent of pi over 4 is 1 is that, again, at pi over 4 they're the same. So root 2 over root 2 is root 2 over 2 divided by root 2 over 2 is going to be 1. So then you get minus 1 times tangent of pi over 6, which we also already said was root 3 over 3. And so this gives me 1 plus root 3 over 3 over 1 minus root 3 over 3. Okay, and we can do one more step where we get a common denominator. On a test, this would be fine for me, but if we wanted to get a common denominator, this would become multiplied by 3 over 3. So you get 3 plus root 3 over 3 divided by 3 minus root 3 over 3. And these flip up, and that becomes 3 plus root 3 divided by 3 minus root 3. Now, I'm not as super a stickler on this because technically we're not done yet either. I still have a radical on the bottom, so I would need to do one more step. I would have to do what's called multiplying by the conjugate. We talked about that a little bit with imaginary numbers, and so we can go on a little bit. And I'm going to show you how. I mean, this becomes foiling. But on a test, I don't really care. If you left me with this would be fine with me. But just so you can kind of see it where these numbers come from, then FOIL, and I would get 9 plus that'd be 6 root 3 plus 3, and this would give me 9 minus 3, which would be 6. So 9 minus 3, and so I actually would end up with this. Oops, I'd end up with 12 plus 6 root 3 all over 6. 9 minus 3 is 6. And I could factor out that, and I would be left with 2 plus root 3. So that is the nice, pretty answer. Looks much nicer than this answer, but it turns out that these are the same. Okay, and if you're not sure, you can use a calculator to do that, and it turns out they're the same. I'm going to pause the video and bring up my calculator real quick, and you'll see why. Okay, and we're back, so sorry about that. So I didn't have my calculator up. So we're back here with the calculator. We can kind of see that they're the same number. Again, it's not as important to me, but just in case you didn't believe me. So the first number here is 2 plus root 3. Okay, so 3.73. If we take that same answer and we just do the answer I had from before, root 3 divided by 3, let me wrap that in parentheses. I can insert, boom, boom, boom. 1 plus root 3 over 3, okay, divided by, in parentheses, 1 minus root 3 divided by 3, close that parentheses. I think we're all good on the parentheses now. And we get the same number. So they're the same. Now, I don't want you to give me a decimal answer, because you can just plop this right in, FYI. You could just plop this problem in, which was originally tangent of 5 pi over 12. So make sure I'm in the right mode. You could just do 5 pi divided by 12. And guess what? You're going to get the same answer. But again, that's not showing me that you've applied the formulas and that you know these identities, and then it's really our good use of unit circle as well. So just doing tangent of 5 pi over 12 to get this decimal is inappropriate. It's not what I want. Also, just getting a decimal is not appropriate. But if you showed me that you either got this or that you went all the way and got that, either way is fine with me. Okay? They were both valid for me. You can definitely use your calculator to check, though, if you're not sure on your answer. Okay, so hopefully I have enough room here to finish this out. I hope that I can go on as much as I need. But let's verify this identity. Sine of alpha plus beta plus sine of alpha minus beta equals 2 sine. Okay, so I'm going to definitely start on the left-hand side. It's the more complicated side. And it looks like I can use the addition formula and the subtraction formula. So I'm going to need those, so I'm going to mosey on up here. Hopefully my computer doesn't crash. And it looks like sine of alpha plus beta is sine alpha cosine plus cosine sine. So sine cosine plus cosine sine. So this is equal to sine alpha cosine beta plus cosine alpha sine beta. Looks like my computer might not make it, folks. It's starting again. Okay. All right, come on, buddy. Okay, so that's the first one. Let's go ahead and take care of that. So for this first one, it's going to be sine alpha cosine beta plus cosine alpha sine beta. So that was this. Went here and here. And now let's talk about what the identity is for sine of alpha minus beta. Okay, so sine of alpha minus beta is going to be the same thing, except it just has a negative sign, so that's nice. So sine cosine minus cosine sine, sine cosine minus cosine sine, sine cosine minus cosine sine. Okay, so it's going to be minus, or plus sine cosine minus cosine sine. Okay, so almost running out of room here, but I think we're going to be able to get it. So what's cool about this one is that these are like terms. This cosine alpha sine beta, cosine alpha sine beta. In fact, they actually just cancel out. And again, just to kind of recap, this thing right here produced these two terms, this guy, and this guy produced those two terms. But what was cool is that they were like, these two are like terms, so they canceled out, and now I'm just left with these two, which actually are also like terms, sine alpha cosine beta, sine alpha cosine beta. And these are getting added, and so my answer is going to be, I have two of them. One apple plus another apple makes two apples. So I have two sine alphas cosine betas. And guess what? That was the right-hand side. Okay, so we're done. All right, so we did these identities here together. We worked backwards and forwards. You know, if we had them split up, we didn't have to do anything. But if we did split them up, we went ahead and did it. I asked just a couple more for practice on these problems here. I'll write the answers and I'll post them on Canvas. Other than that, I thank you, and I'll see you on the next video.